trigonometric derivatives, product rule, Lagrange's notation. So in a previous video I explained that the product rule was hx, the function hx, and that within that function there was a function called fx multiplied by another function called gx. So you technically have two functions multiplied by one another within a function. And when you want to derive said function, you have to do the following steps. Derive the first function by multiplying it by the second function, then adding the first function, multiplying it by the derivative of the second function. So now we've got that out of the way, do an example. Okay, so example 1, hx equals negative 2x multiplied by cos x. So you have your first function, negative 2x, and your second function, cos x. So if we rewrite this, let's say fx gx. So if we separate the page, we can write fx as being negative 2x, and we'll say gx is cos x. Now, to derive this, put in the rule. Derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. So, we need to find the derivative of the first function and the derivative of the second function in order to complete this. So, the derivative of fx is just negative 2, and the derivative of gx is negative sine x, because cos x goes to negative sine goes to negative cos, and negative cos goes to positive sine, and so on. But in this case, cos goes to negative sine. So, if we fill this in, okay, so fx, negative 2, multiplied by gx, cos x, and then plus fx, which is just negative 2x, multiplied by derivative of gx, which is negative sine x. So, by having a negative times a negative, obviously they cancel out. And because there's, and so it'll just be negative 2 cos x plus 2x sine x. And to rearrange it to make it look neater, we'll just bring the negative over here and we'll put that out the front. So it'll end up being 2x sine x minus 2 cos x. That is the first derivative of this function up here. Okay, now another example. Cos x multiplied by tan x. First function, second function. You write that, fx multiplied by gx. Squeeze it in here. Have fx equal to cos x, and tan x, gx equal to tan x. So the formula for the derivative is of the h function is derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. So yet again, we need to find the derivative of gx and the derivative of fx. Derivative of cosine of x is negative sine x, and derivative of tan x is sec squared x. So now we have them, we can fill it in. Derivative of fx, negative sine x, multiplied by gx, tan x, plus fx, cosine of x, multiplied by derivative of gx, which is sec squared x. So we can rearrange this as cosine x multiplied by sec squared x minus sine x multiplied by tan x. All I did there was just bring this around here because of the negative, make it look neater. Okay, so final example. Cosec x and cot x. So yet again, first function, second function. So we'll call fx is equal to cosec x and gx is equal to cot x. So the derivative, same again, derivative of first function multiplied by second function plus first function multiplied by derivative of second function. So we need to find the derivative of fx and the derivative of gx. So the derivative of cosec x is negative cosec x multiplied by cot x. And the derivative of cot x is negative cosec squared x. Okay, so we just fill this in. F dash negative cosec x multiplied by cot x multiplied by gx, which is cot x, plus fx, which is cosec x, multiplied by the derivative of gx, which is negative cosec squared x. So we can rewrite this as negative cosec x multiplied by cot squared x, because there's two, multiplying them, and minus, subtract cosec cubed, because we're multiplying, we're essentially doing cosec multiplied by cosec again, and we've got the negative. So that's how it works. And that there is the first derivative of this function up here. Thank you for watching. Hope this helps.